trends in the K-12 education. And one of those things just happens to be 3D printing. So we're going to talk a little bit about that. I do have a kind of a canned thing that I can go through as we move along. And really, for the most part, it's going to follow what I talked about in our Intro to 3D Printing workshop that we offer on Thursday nights. You have the handout for that. You have the what is 3D printing guide in front of you as well. I'm giving you all of that so you can get some notes, so you can listen more and hopefully ask questions. If you want to go off in some direction, please just ask. I'll be more than happy to explore for you. Or I can just do the same old talk I've done a dozen times. Please save me from that. So I'll probably spend the most time on this slide, today's takeaway. Because really they are just that important, especially that first one. The largest barrier is learning new software. So in the summer of 2015, our assistant director for public services said, "Hey, Dan, guess what? I just bought a 3D printer yesterday. It's going to be here in 2 weeks. I want you to lead it. Starting the this year in the library." I said, "Great. I've never touched a 3D printer in my life." And so everything I know is about 3D printing has just happened in that last year and a half. What I do not have a lot of experience with yet is learning new software. There's a huge learning curve. So there are some programs out there. So on your intro handout, on the front side, right-hand side, there's some controls and shortcuts for Tinkercad. Tinkercad is a very elementary program. It's web-based, tinkercad.com. It's geared towards the elementary crowd, but those kids work with solid objects, block text. It's all drag and drop. It's pretty easy to pick up, but it's a great way to introduce yourself to 3D modeling software. If you want to do more, you'll find out that it can become very limiting very quickly. You have to learn something new. And it's that software that it's the reason why 3D printing hasn't taken off the way people thought it would. So a lot of manufacturers believe that they can get a 3D printer in every house in the next 5 or 10 years. Not going to happen. Why? It's the software. People need to know how to make things themselves, either as a replacement volume button for your car, or the door handle to open up your dishwasher, or that knob to start your dishwasher. I'll give you an example from my life. Your shelf for your refrigerator, because mine snapped in half. Those crazy kids. You need to learn how to model things and create things on your own. And too many people don't know how to do it because they don't have the time nor the desire to do it. And so that's why ECU and a lot of K-12 schools start pushing 3D printing and 3D modeling in high school. So that 3D printer in every house could happen, but it'll probably take about 40 to 50 years. So an example of learning new software leads me into money's in the design, not the final object. So here's the example idea. So that Formosan black bear, used to be lying around here somewhere. Let's head out backwards. So this guy, I love to talk about this guy because he's a really good example, and because the design team that put him together talked about the process on the wall. So it gives me something to talk about. This guy took 6 hours to print. printed the black parts separately from the white parts, and then everything kind of press fits together. It took that engineering design team 10 hours to create that paper mache model you see in front of you. It took them 40 hours. Model. So it's on the screen. It gets a little complicated. They have these two little clasps that go around the cylinder, which is on the arm, and then it gets shoved into the arm socket. So everything needs to be able to fit perfectly and press fit, so that arm doesn't fall off, the head doesn't come off, the white parts get pushed into the black parts and then don't pop out. 20 hours. So 30 hours total. Anybody want to take a guess on how much it cost us to print this? How much? 30? No, less. It weighs 56 grams. That's how much we charge per gram of film we use. So, and you cost of the material. Worth of plastic.
$30 labor.
Hours of engineering labor.
Yeah.
And how much do you experienced engineers make approximately per hour?
More.
Yeah, that's much more than that. Any guesses? It's here. On average, about $100 an hour. So $1,000 worth of labor and something costs $2.80 for plastic. Makeover one night here in the library. And so the money's in the design, not in the final product. Part of what the industry wants to do, say Maytag, you call them up and say, hey, my refrigerator's broken, this plastic part came off, I need a new one. They'll say, sure, turn on your 3D printer. Make sure it's connected to the Wi-Fi. And they'll stream that part to your printer and